Break It Down: How Scientists Separate Mixtures by Jonathan Curley and Ashley Chase. We have a diagram of milk, and we usually see a milk in white color, and it definitely looks uniform, meaning it has the same color and it has the same texture. But milk is actually a type of mixture substance. Okay, so page number 5. Most matter is mixed. You are all mixed up. It's not that you are confused. You are mixed up in another way. In fact, you are a mixture of thousands of different substances. You're not alone. Most matter is mixed. Almost everything in the world is a mixture of different substances. A substance is something that is made of only one kind of atom or molecule, such as gold or water. We don't often find substances on their own in nature because they are almost always part of a mixture. All right, let's first look at the first diagram. And so these models show a few of different kinds of molecules that make up milk. Okay, so we have milk here. We have water molecules. Okay, so water molecules. We have protein molecules. Another type of molecules. So protein is on its own. Then we have also fat molecules. And then we have sugar molecules. So what type of molecules are there? So we got sugar, we got fat, we have protein, and water. 1, 2, 3, 4. 4 different type of molecules make up milk. Okay, moving on. Think of milk. Milk may look just one substance. Milk may look like just one substance, but it's not. Milk is a mixture. There is no such thing as a milk molecule. Milk is a mixture of water molecules, protein molecules, sugar molecules, fat molecules, and more. Apple juice is also a mixture of molecules, including water molecules, sugar molecules, and acid molecules. Paint, tears, and liquid soap are all mixtures too. Not all mixtures are liquids. Rocks, soils, bricks, and many other solids are mixtures. Even gases can be mixtures. The air on Earth is a mixture of oxygen and other gases. That's so cool. Oh, let's look at the diagrams that are at the bottom. All right. Here we have a rock. In some mixtures, such as this rock, you can see the different parts. All right, what do we have here? Let's see. Let's zoom it in. So we have, I could see quartz embedded in this little rock. Maybe copper as well. This kind of dark brown part, perhaps that's copper. Maybe gold as well. Do I see yellow? Shades of yellow, also part of the rock. All right, we don't know yet, but I'm just making an inference. I'm guessing based on what I see. Okay, so here's another diagram. In other mixtures such as this apple juice, you can see the different parts. But this apple juice is also made up of different molecules. Okay, let's move on to the next one. Scientists break mixtures down. People make some mixtures such as paint and brick, but most mixtures are not made by people. Most mixtures are just naturally mixed together. Scientists often want to break these mixtures down into parts because breaking a mixture can help scientists understand better. When scientists break a mixture down, they can find out what substances are in the mixture. This can help scientists identify that mixture or figure out what it is. Okay, so one example of breaking down the mixtures is by carrying out the chromatography experiment, the one that we saw last time in our session. Okay, so let's go into the diagrams. All right, let's see. Soil is a natural mixture. Very cool. Okay, paint is a mixture made by people, definitely. Okay, two types of paint. Mixed paint colors are hard to separate. Breaking a mixture down can also make it more useful. Sometimes a scientist wants to use just one part of a mixture, so they separate the mixture into its parts to get the part they want. Mixtures can be hard to separate. Mixing two different colors of paint together is easy, but how can you separate the colors once they are mixed? This book looks at three mixtures and how scientists break each mixture down. Break it down to solve problems. Most of the water on Earth is in the ocean. Ocean water is a mixture of water and different kinds of salt, and it is much too salty for people to drink. In some parts of the world, there is very little water for drinking, but plenty of ocean water is available. Making salty ocean water safe to drink helps people in these places. However, water must be separated from the rest of mixtures. Okay, this city is in a desert that is next to the ocean. Drinking water for the city comes from separated ocean water. Oh, wow. Wonder what city that is. Water and salt have different properties, things about matter that people can see, feel, smell, hear, taste, or measure. Differences in the properties of matter are caused by differences in the properties of the atoms and molecules that make up the matter. For example, water molecules are smaller than many other kinds of molecules. Scientists have figured out how to use this property of water molecules to separate pure water from salty ocean water mixture. Ocean water is pumped through pipes and then pushed through a filter with holes in it that are much too small to see. The tiny water molecules in the ocean water mixture are small enough to pass through the filter, but the atoms that make the water salty remain trapped. Only pure water comes out on the other side of the filter, and this water is safe for people to drink. Okay, so this is a diagram that shows separation of ocean water to make it pure water or drinking water. All right, so separating pure water from salty water. Okay, salty water, this the salty water that comes from the ocean. And then there's a filter, a device that separates salt from water that makes the ocean water. And after the salty water goes through the filter, what remains is pure water. So this diagram shows how water can be separated from a mixture of water and salt using a kind of filter.